So, what exactly is this? Well, it's our new theory to explain how the universe operates and increase our understanding of gravity. And what's it called? Loop quantum gravity, which will combine the effects of general relativity and quantum mechanics. Wait, I thought that was impossible. Not exactly. You see, loop quantum gravity, or LQG, aims to bridge the gap between general relativity, which describes gravity in space-time on larger scales, and quantum mechanics, which describes particles at the smallest scales. A major challenge is that general relativity labels space-time as a continuous fabric, where space and time can be infinitesimally small. However, quantum mechanics suggests uncertainty and discreteness when it comes to particle positions and momentum. To reconcile these views, LQG proposes that both space and time are now quantized. This means that there exists a smallest unit of space, which is 10 to the negative 35 meters, and a smallest unit of time, which is 10 to the negative 43 seconds. This can be seen similar to a movie, where seconds are broken down into their discrete frames, and each of these frames consists of individual pixels. In this framework, space is visualized as being made up of loops, where all of these loops come together to form what is known as the spin network. Each of these loops represent a quantized unit of space, all interwoven to create the fabric of our universe. Gravity emerges as particles interact with our spin network, where the effects of these interactions can be observed at the smallest units of both space and time. When particles interact with this spin network, the connections and intersections formed by these loops describe the curvature of space-time, or as we perceive, gravity. Essentially, the geometry defined by the spin network will dictate how both mass and energy warp space-time, thus giving rise to gravitational effects.